Hi guys, welcome to Mini Talk in Chemistry. Today we will talk about the Buchwald-Hartwig cross-coupling reaction, a useful way to make a carbon sp2 nitrogen bond. We will see some application in the literature, then understand the catalytic cycle and how it can be used as an alternative of the Ullmann reaction, and finally, how to choose the optimal condition. In general, this reaction took place between an electrophile partner such as aryl or heteroaryl halide or pseudohalide such as triflate, torsilate, or mesylate, and a nucleophile partner like a primary or secondary amine. In the presence of a palladium catalyst, a phosphine ligand base to provide secondary or tertiary amine. Third example is a reaction between 2,6-dichloropyrazine and nitroaniline derivatives in the presence of palladium acetate, racbinap, cesium carbonate in toluene at 90 degrees in 23 hours to form a secondary aryl amine. The long-time reaction is probably due to the presence of a nitro group in the nucleophile partner. The second example is a reaction between the dibromo biphenyl and a primary amine in different conditions to form the carbazole scaffold. This reaction was used in the total synthesis of muriazoline, published in 2008. Now let's move on to the general mechanism of the Buchwald-Hartwig cross-coupling reaction. The catalytic cycle begins with oxidative addition of the aryl halide to the palladium-0 species. The resulting palladium-2 complex reacts with amine and base to form palladium-nitrogen bond. This palladium-nitrogen bond can form by different mechanisms in function of the strength of the base. And the last step is reductive elimination to regenerate the palladium-0 and the desired product. In this last step, we can get the undesired product such as dehalogenated product and imine. The Buchwald-Hartwig cross-coupling reaction were used to form the secondary or tertiary aryl amine, but primary aryl amine can also be formed by reaction of aryl halide to ammonia or equivalent of ammonia like LEHMDS. You may know that other nucleophile partners can be used such as amide or alcohol to form aryl amide or aryl ether, an alternative of the Ullmann reaction. Finally, the reaction condition is easy to find many examples in the literature. To make it short, palladium-0 or palladium-2 can be used, and for palladium-2, which is more stable in air but requires amines containing alpha hydrogen to be reduced to palladium-0, the choice of ligand was crucial depending on the nucleophile partners. For example, phosphors were used selectively for primary alkyl amines and primary anilines, while TBU phosphors were used for less reactive nucleophile partner like amide. All ligands are commercially available. A wide range of bases can be used, each with advantages and limitations. For example, cesium carbonate has good functional group tolerance and reaction rate, but it's pricey and hard to stir on a large scale. On the other hand, potassium phosphate is economically attractive and has excellent functional group tolerance, but it requires high catalyst loading and long-time reaction. The reaction can be done in toluene, terbutanol, dioxane, THF, or DME. It's not really water sensitive because you can sometimes 4% of water is added intentionally to help the palladium-2 reduction. The reaction requires inner atmosphere but not very sensitive to oxygen, and you can use conventional heating or microwave heating. Personally, I already make this reaction many times just by adding the electrophile and nucleophile partners with the solvent, degazing the mixture, and then added base, catalyst, and ligand, and degaze again, and then submit it in conventional heating or microwave heating. It works very well. And for more details about how to choose the best condition, you can check this reference. I hope you understand the Buchwald cross-coupling reaction better now. Thank you for watching and see you next time.